Okay, so here's the foundation for sequences. We are going to study two types of sequences, and the names of them are arithmetic and geometric. Those are the two different sequences we're going to study. So what's the difference between them? So an arithmetic sequence is going to be, what are you adding? What are you adding to the sequence? Versus the geometric, so I'm just going to scroll down a little bit. What is a geometric? It's going to be, what am I timesing? How do you spell that word? I don't know. Anybody know English? What are you multiplying by? Timesing, because that does not look right, does it? Hence why I'm not an English teacher. Is that even a word? Maybe it's not a word. Okay, so what am I adding? What am I multiplying? Those are the difference in what's happening. Okay, so here we go. What am I adding? The word for that number is called a difference. Okay, so what's the difference? What's happening every time? And you will probably be able to see it. What's going on? How did I get from a 3 to 7? And then the same thing, how did I get from that 7 to 11? What's the pattern? You're adding 4 every time. Okay, what if you don't see it? Okay, because this was an obvious one. What if I don't see it? Here's what I can do. I can take a term, any term, and subtract the one before it. So pick me any term. Doesn't matter, except for 3, because there's nothing before it. 19, 15, whatever. 15. Subtract the 1 before it. And what do you get? 4. Okay, number 2. You might be able to just see this. So what is happening each time? Minus 6, I'm going down 6 each time. Okay, so obviously a negative number, because you're adding negative, you're going down. So again, if you don't see it, you can always take a term, subtract the one before it. So what if I did negative 17, subtract negative 11? That's what it would be. There'd be lots of negatives involved, right? Okay, what's happening each time on number 3? Guess what? Can you see it? Because I can't. Okay, so here's what I'm going to do, because I can't just see it. So I'm going to do this. I'm going to take some kind of term and subtract its previous. So which term do you want to pick?
11 over 12.
11 over 12, subtract the 1 before it. Okay. No calculators? How am I going to do this? How do I add and subtract fractions? Common denominator. So here's what I'm going to do. I'm going to change this one from a 4 to a 12, which means I change the top to a 3, which means I get 8/12. So that's what I'm doing each time. I'm adding 8/12. Or we could reduce it and call it something else too. 2/3. Doesn't matter. Okay. Okay, last question. An arithmetic term has 33 as its 5th term. And 63 as its 10th term. So there was a pattern. So that's what I know. and I need to figure out what's happening, and then I also need to figure out the first term. Okay, so here's my first question. What did I add all the way across? From here all the way to there, what have you added? 30. Okay, I had to add a number, add that number, add that number, add that number, add that number. Okay, how many times did I add whatever number this was? 5. So I'm going to call it like this. I did 5 of those differences, and then it was a total of 30. So then if I divided by those 5 moves, what was each move? 6. So the common difference was that I was adding 6 each time. And then it says, could you figure out term 1? So I'm going to get the first term, so that's whatever's on this blank. So I'm going to have to go what? What am I doing each time here? I'm going down 6, down 6, down 6. How many maneuvers would I have to do it to get from the 5th position to the 1st position? 4. I have to go down 6, 4 jumps of it. So, how am I going to write that in math? I was at 33, and I had to go down 6 times 4. There's 4 increments of that minus 6. So now what am I at here? What'd you say, 9? 9. Okay. On the test, if you really want to see if you're right, you can put other numbers in here, like up 6 would be 15, 21, 27. Oh, good. I hit 33. Up 6, 39, 45, 51, 57. Boom, 63. Okay, if you really wanted to see if you did it right. Okay, arithmetic. Good. So what's the difference between that and geometric? Multiplying. Okay, so number 1, you can probably see it. What's going on in the pattern? How did I go from a 4 to an 8, and then the 8 to the 16, 16 to 32? What's happening every time?
32.
You're timesing by a 2. Yep. So, what if I don't see it? Because this was a little bit obvious. If I don't see it, what am I going to do? I'm going to take a term and divide by a previous. Because to see what am I multiplying by, I do a backwards division. So I could take any term like 16, and if I divide by the one in front of it. Okay, number 2, might be able to just see it. What are you multiplying by? How did you go from a 5 to a negative 15? Negative 15 to a positive 45? I'm timesing by a negative 3. Okay, obviously you got to recognize the negative by positive, negative, positive, negative. And if you don't see it, you can take any term like negative 15 and divide by the thing in front of it, the term in front of it. Okay. This is me trying to be a little bit tricky. What are you multiplying by? What are you multiplying by?
Less than 1.
What are you multiplying by?
Less than 1.
Less than 1. So it's a fraction. So we're multiplying by a fraction. How did Ben know that? Because we were getting smaller. How do you get smaller in math? You got to times by a small number, a decimal or a fraction. Okay. Can anybody tell me what the ratio between a 20 and a 60 is? And a 60 to a 180. What's that ratio between them? 3. So this would be multiplying by 1/3. Okay, so recognizing in a geometric, if you get smaller, you have to be multiplying by something less than 1. If you don't see it, what do? Take a term and divide by something in front of it. That's fine. Yep, it's the same thing. Okay. Last one is a fraction. Probably guessing you don't recognize it as soon as you see fraction. So we're just going to start term divided by previous. Okay, which ones do we want to pick here? 1/6 divide by the 1/3. What kind of math work do you do when you're dividing fractions? What's the key ingredient? What should you do? Dividing some fractions. What's the process? 1/6. What do you do with all the rest of it? Times and flip. Remember? Dividing fractions, times flip. So I found out I'm timesing by a half. That makes sense because I'm getting smaller, right? 2/3 and then 1/3. Yeah. Divided. I'm getting smaller. Okay, last geometric question here. 1, 2, 3, 4th term. 5, 6, 7th term. Okay, so we have to do the same pattern. We're going to figure out what's the pattern, figure out the term 1. Okay, here's my first question for you. What did you multiply by in that whole span? What's the multiplier that moves that all together?
27.
27. Okay, so now what did I do here? I'm going to go, I times by some r. I'm going to call it an r because it's a ratio. I times by an r, and then I times by an r, and I got there. So who can tell me what to do in math when I times by r, times by r, times by r? What's that same process in math? If you times an r, and times an r, if you times something a bunch of times, what should you do to it? Okay, how about I do this to you? What if I do 5 times 5? How else could you show me that in math? 5 squared. Okay, so what could I do if I went r times r times r? R cubed. If I times something, times something, times something, r cubed is 27. Okay, how do I solve this? How do you undo a cube?
Cube root.
You cubed root. Okay, do you know how to type that into your own calculator? Okay, I'm going to show you my button because you might be the same. So I have to push the 3 first, and then I have this button right here called the any root. So then I go shift that. So I'm not sure if yours is the same. Some of you might just have cube root buttons straight. So mine is the any root button, and I have to push the 3 first. Okay, anybody not find their button for that process? Because then you gotta wave me over so I can show you where it is. Cube root of 27 is 3. 3 times 3 times 3. Okay, so R is 3. That's my multiplier. So how do I figure out the first in this? What would you do to work backwards? You would have to divide by 3, divide by 3, divide by 3. Or what else could you type quickly instead of dividing by 3, dividing by 3, dividing by 3? You could divide by 3 repeated 3 times like that. Okay, so 378 divided by 3 cubed. So there's my symbol for cubing that button. And I get, did you get 14? So the first term is 14.